Hi, welcome on. So today we are looking some projects in power electronics. The project title is Residential Commercial Community Load Management based on optimal design of standalone HRS with model predictive control, that is MPC controller. So in this paper, author had proposed one MPC control mechanism for smart grid, which has multiple renewable energy sources. Renewable energy sources might be solar, PV, wind, battery, diesel source, etc. So that sources are connected to the DC bus. This DC bus is connected to the reconfigurable inverter, which gives the AC supply to our load. So here is the MPC controller who manage all the communication between the DC bus and AC bus in terms of power, current, and voltage and all. So this is the basic structure we had created. So in that we are going to monitor disturbance and voltage, predictive voltage, and its cost function to maintain the SMC configuration. So here we can see the our HRES structure, that is proposed HRES structure. In that wind, PV, battery storage, and diesel is taken. So all these DC sources, wind, PV, and battery storage is connected to the converter, and then it is giving supply to the AC bus. Diesel is giving the AC bus supply directly, and the supply is consumed by the primary load. In terms of load, we are going to see various loads like home, residential load, industrial load, critical industrial load, that is heavy industrial load, like electric vehicle charging station, etc. This is a basic structure which we are going to analyze. This is the section like where SMC control take the decision based on the power supply, that is load requirement and available sources. So we are going to analyze various aspects of this section. This is more elaborated structure where PV generation unit, wind generation unit, battery storage unit is connected to the DC bus, and all these bus were monitored by the MPC EMS, that is MPC controller, which is giving the power the control signal to the inverter and switch that is attached to the residential load after the AC bus. So this is how circuit is maintained. We are going to monitor various characteristics of the circuit, that is power, PV relation, wind speed, voltage, and power coefficients, different that is battery associate percentile. These are the various properties which we will analyze from the existing system. Afterwards we'll see that is how MPC controller is performing the better solution than existing system. This is how this project is elaborated. So we'll start with the simulation. Here we have created one simulate model in the simulation. So in this simulate model we can see since the model is very big, it is in zoom in manner. So I'll elaborate. This part is battery model, this part is fuel cell, this part is wind turbine, wind generator. This is solar PV model which is connected to the two bus, that is AC bus. This supply is connected to the grid as well, and after the grid we are showing some load, that is non-critical and critical load. So this is non-critical load, that is household, and this is critical load, that is industrial load. So we are we have created the MPC controller here, which is taking the MO, that is observations from our produced data. That is, all the 6 inputs were given to MPC controller, and produced voltage, that is outcome of all these 5 systems is given as a reference to the MPC controller, which is producing the lambda UV, which is given to the circuit breaker, that is switch to all loads. These are different type of loads which we are which we have connected in the system. So we'll see how this system is performing. Initially, before starting the system, we have to load some simulation properties over here. So we'll load the PV model characteristics here. These PV model characteristics are given as an input to the system. So this PV model has that is data has various characteristics like alpha, beta, different values. There are lots of values which we are given. These values were specified in this paper in various sections, like different characteristics like KPKI, maximum power, wind. There are lots of properties which are given. These properties were converted in this uh, PV model data.mat file. Once we load that mat file, we have to run the simulation. Once we run the simulation, it will first compile the outcome. So we'll see how it is working. So after compilation, it will start executing. It will give some plots for different section. See, simulation is started. It is showing some SOC. There are various values SOC current voltage, which we can see here. See, this is how current voltage and SOC is printed for battery model. Then we'll see different things. We'll go to the SMC controller. Here we can see the power and uh, voltage produced by our system, which is final outcome of the system. We'll see another graphs. Here we have used fuel cell. We'll see the different type of gases emitted by the fuel cell, that is H2, H2O and O2. That these are the different type of gases and liquids emission by the fuel cell. This is the graph for liquid fuel cell. Then we'll go to the wind turbine model. This is wind turbine model. So here we can see speed of wind speed, armature current and electric torque here. So this is how it is being represented. You can see a clear graph for that. First graph is current, that is second is torque, and third is wind speed per second. Okay, so our simulation is completed. Uh, this is how we can see power generated by our system, power graph by wind turbine. We'll go back to base model. Okay. Here we have given a PV array model which is generating the power to our system, which is given to a bus. Okay, so now we have completed the simulation and shown how simulation is working. Uh, After this simulation, we have to plot various graphs related to final outcome. I'll show you how to plot the graph. For plotting the graph, I have created one function, that is result.m. So here we have taken all the parameter from various like battery, solar, fuel cell, hydro, wind, and all column signals were taken. We are plotting the graph with respect to the various utilization of energy. We'll run this graph on here. So once we run, it will plot various graph. We'll see one by one. So this is the graph which shows the power utilization of heavy industry in terms of various, like we have created the 24-hour simulation. See, 0 to 25 values is there, so up to 24 it is plotting the value. So this is 24-hour simulation. Within the 24-hour, how this heavy industry is utilizing various power. These are various power provided by different sources like the battery, solar, house, fuel, hydro, wind, and all. So all respective colors is presenting the total power consumption from various sources by heavy industry. Likewise, you can see here, this is the power consumption by different small industry. We have created 5 small industry model. So this 5 industry model is consuming this power from various sources. Same, we have created 24 hours model, simulation model, and it is generating the graph for power consumption from various sources. As like the sources from various industry, we have created the house model as well. So this is the model which showing 5 houses, house 1 2 3 4 5 6, which is consuming power from our different sources. So all the colors show representing how much power is consumed by various at various time attempt of time, and the power is shown in kilowatts. So for heavy industry it is into the kilowatt, for sorry, for industry it is in kilowatt, and for heavy industry it is in megawatt. So this is how this system is represented, and based on this simulation we can show that we have created one hybrid grid, a smart grid, which has different sources like solar, fuel cell, wind turbine. This is again this is different fuel cell, and this is different fuel cell, and a battery, and which is controlled by SMC controller and giving the input to our loads. So this is how we have shown the system. We'll see how this system is similar to this best paper. See, here is one system presented by the other here. See, here they have created three sources: PV, wind, and battery. These three sources, along with our own contribution, we have taken other sources too, like fuel cell and all. So these sources is giving their production output to MPC controller, and MPC controller is giving data to load. This is how we have evaluated our system, and hence the system is proven. And based on our output, it is shown that our system is giving the better outcome in terms of different kind of results. Like we can see this graph as an outcome, like how it is showing various, for in terms of, let's say, current and torque. This is showing the stable outcome from various perspective. So this is how we have created the system. Thank you. Amen.